Hi, this is Janagareddy Dubbaka. NCRD problems from the chapter Electrostatics and Capacitors. This is part 2. In part 1, we discussed about around 15 problems. In this video also, we are going to discuss another 15 problems. These are from NCRT textbook or NCRT model problems. See here, two charged spheres having radii A and B are joined with a wire. The ratio of electric field EA by EB on their surface. When two spheres are connected with a wire, the charge flows from one sphere to another sphere until their potentials are equal. Therefore, V is equal to KQ by R. Therefore, here potential constant, K constant, Q proportional to R. This becomes Q1 by Q2 is equal to R1 by R2. Here, radius of the first sphere is A and this is P. But intensity E is equal to KQ by R square. Therefore, E1 by E2 is equal to Q1 by Q2 into R2 by R1 whole square. Therefore, E1 by E2 is equal to, here Q1 by Q2 is equal to A by B, but R2 by R1 means B by A whole square. This becomes A by B into B square by A square. Therefore, here B square B cancel, A square A cancel. This becomes B by A. Therefore, option 2 is correct. Next one. 4 electric charges plus Q, minus Q and minus Q are placed at the corners of a square of side 2L. The electric potential at point A midway between the two charges plus Q and plus Q. See, here is 1 plus Q, here is N plus Q. I have to find out the potential at midway between these two at point A. See, here potential is a scalar. Therefore, in the system, there are 4 charges. Therefore, there are 4 potentials. Therefore, total potential V is equal to V1 plus V2 plus V3 plus V4. Here, the total distance is 2L. Therefore, this is L, this is L. And from this charge, we have to find out this distance and also this one. Here, this distance is 2L, here is L. Therefore, this becomes root 5L. This one also root 5L. Therefore, V is equal to V1 plus V2 plus V3 plus V4. Therefore, V is equal to, due to this charge, here I am 1 by 4 pi epsilon I am taking K into Q by L. See here one important thing, in potential formula, the charge should be substituted with sign. If it is plus, we have to substitute with plus. If it is negative, we have to substitute with negative. That is very, very important one. Next one, another KQ by L. Here is minus, therefore, minus KQ by root 5L. And this one also minus KQ by root 5L. Therefore, V is equal to 2KQ by L minus 2KQ by root 5L. Therefore, here V is equal to, here 2KQ by L common. This becomes 1 minus 1 by root 5. Therefore, this becomes K means 1 by 4 pi epsilon naught. And 2Q by L, this is 1 minus 1 by root 5. Therefore, the answer is third one. Next one. The correct relation between E and V. See here, E bar is equal to minus dV by dr bar, or dV is equal to E bar dot dr bar minus E bar dot dr bar. Therefore, Third option is correct. Next one. A charged particle of charge q is held fixed and another charged particle of mass m, charge q of same sign, is released from a distance r. The impulse of the force exerted by external agent on a fixed charge by the time the distance between q and q becomes 2r. See here, this is the charge q. Charge q, this one is fixed. Here another charge q, it is at a distance r. At a distance r. Therefore, due to this repulsion force, this charge moves. When its distance becomes 2r, the impulse of force exerted by external agent on fixed charge by a time at a distance q and q becomes 2r, means this is r. At this its velocity is v. Impulse means change in momentum. Initially it is at rest, therefore initial momentum 0. Therefore impulse is equal to final momentum minus initial momentum. Therefore impulse is equal to m into v. We have to find out v. For this one we have to apply law of conservation of energy. See, initially these two charges are at a distance r and it is at rest. Therefore total energy initial, that is equal to total energy final. Initially there is a potential energy, that is 1 by 4 pi epsilon 1 by 4 pi epsilon q into q by r, kinetic energy 0. Next one, at this position the distance between small q and capital Q is 2r and it is having velocity. Therefore potential energy 1 by 4 pi epsilon q into q by 2r plus kinetic energy of mv square. From this, of mv square is equal to 1 by 4 pi epsilon q into q by r minus 1 by 4 pi epsilon q into q by 2r. Therefore, of mv square is equal to 1 by 4 pi epsilon q into q by 2r. Therefore, here this 2 gets cancelled. V square is equal to q into q by 4 pi epsilon 0. Here m into r. Then V is equal to square root of q into q by 4 pi epsilon 0 m into r. This is velocity. Therefore, impulse I is equal to mass into velocity. Therefore, when this mass is taken into root, this becomes m square. Therefore, m square into q by 4 pi epsilon 0 m into r. Here, this m square, m gets cancelled. Therefore, impulse is equal to square root of q into q m by 4 pi epsilon 0 r. Therefore, option 2 is correct. Next, 3 very large conducting plates with charges are placed as shown in the figure. Charge on left side of surface of plate A. See here, this is the plate A. This is the plate B. And this is a plate C. See here the extreme faces. This one having the charge, we have to divide the total, we have to add the total charge and divide it by 2. Therefore, this becomes 5q minus 3q minus 2q by 2. Therefore, here minus 3q minus 3q minus 5q. Therefore, this becomes 0. Therefore, this side and this surface having charge 0. But here the charge on the left side of surface plate A is equal to 0. Therefore, answer 0. If you want to find out the other phases also, by charge conservation, initially here is 5q. Therefore, 0, this side becomes 5q. But a facing surface having equal and opposite charge, this is 5q. Therefore, this becomes minus 5q. But charge conservation here is minus 3q, here is minus 5q. Therefore, this side becomes 2q. Therefore, minus 5q plus 2q minus 3q. Again, this is 2q and this side is opposite charge and equal magnitude, and this one is minus 2q. Therefore, and here minus 2q plus 0 minus 2q. This is the charge distribution. Next, a hollow metallic sphere with a charge q at the center is shown. Which of the following options is correct? So here, inside this one, here is a charge, there is an electric field at A. Therefore, electric field at A does not equal to 0. Electric field at C also does not equal to 0. But point B is inside the conductor. Therefore, EB is equal to 0. Therefore, here EA does not equal to 0. EB is equal to 0 and EC does not equal to 0. Therefore, answer EA does not equal to 0. First option correct. So here, the capacitance of a parallel filled capacitor is C. This becomes C is equal to A epsilon 0 by D. If it is off filled with a dielectric constant K, the new capacitance will be. See, whenever the distance divides the dielectric, the two capacitors are in series. When area divides, that capacitors are in parallel. Now I'm taking, this is the capacitance C1, this is C2. Therefore, C1 is equal to A epsilon, here is filled with air, therefore dielectric constant 1, A epsilon, and this distance is D by 2. Therefore, 2 A epsilon 0 by D, but A epsilon 0 by D is C, this becomes 2C. Similarly, C2 is equal to, here also same distance but dielectric constant K, this becomes 2KC. But here C1 and C2 are in series. Therefore, C equivalent is equal to C1 C2 by C1 plus C2. This becomes C1 is 2C and this one is 2KC by 2C plus 2KC. Therefore, C equivalent is equal to 2C into 2KC. Here 2C common, 1 plus K. Therefore, here this 2C gets cancelled. This becomes 2KC by K plus 1. Therefore, 2KC by 1 plus K, answer 2 correct. So here, two thin dielectric slabs of dielectric constant K1 and K2, K1 less than K2, are inserted between the plates of a parallel plate capacitor as shown in the figure. The variation of electric field E between the plates with the distance D as measured from plate P correctly shown. See here, intensity of electric field between the plates E proportional to 1 by K. But here K1 less than K2 means E1 greater than E2. See here, from P to this plate, this is A. Therefore, here intensity of electric field is constant. Constant means straight line, like this. After that, here is the intensity of electric field E1. Here I am taking E2, but E1 greater than E2. Therefore, here E1 greater than E2, it slightly decreases. And after that, otherwise we can find out from options also. See, this I am taking E1. This is E1. This is E2. Here is E1. Here is E2. This is E1. Here is E2. See, from which option E1 greater than E2? See here. See here, K1 less than K2. Therefore, E1 greater than E2. E1 greater than E2. Not this is E2. Why? Because here is uniform field, and after that intensity decreases, here also uniform. Therefore, this is E2. But here E1 less than E2, this is wrong. Here also E1 less than E2, this is wrong. Here E1, E2, sorry, this is E1, this one is E2. Why? Because in between K1 and K2 there is an air, therefore uniform electric field. Therefore here E1 greater than E2, therefore answer 3 correct. Next one. The equivalent capacitance, between A and B. See here, this is the node point A, here also A. Here B, here also B, here also B, here also B. I am taking another node point C and this one also T, C. Here another node point D. Therefore, in this, the node points are one is A, B and C and D. 4 node points are there. We have to find out the capacitance in between A and B. Therefore, here is A, here is B, another node point C, another node point D. Now, here also A. Now, this capacitor is in between A and B. Therefore, remove from here A and B and that capacitor to connect in between A and B. Here I am connecting in between A and B, that is 2. After that, and this one is in between A and C. Therefore, here A and C, here is A and C, another resistor, that is 1. Next one. And here it is in between A and D, A and D, A and D 2. Next one. This becomes D and C, D and C, D and C 7. Next one. This is D and B, D and B 4. Next C and B, C and B, this is 2. Now, it is in the form of Wheatstone bridge. Here is 1 by 2, 2 by 4. 2 by 4 means 1 by 2. Therefore, bridge is said to be in balance. In balance condition, this capacitor can be removed. Now, this 1 and 2 are in series. Therefore, 1 into 2 by 1 plus 2, this becomes 2 by 3. And 2 and 4 also in series. 2 into 4 by 6, that is 4 by 3. Now, this 2 by 3 and here is 2 and here 4 by 3 are in parallel. Therefore, CAB is equal to 2 by 3 plus 2 plus 4 by 3. So here 4 by 3 plus 2 by 3, 6 by 3 plus 2. 6 by 3 means 2. Therefore, 2 plus 2, 4. Therefore, answer is 4 microfarad. Next one. A charged object cannot attract an uncharged object. See, a charged object can attract an uncharged object due to induction. Therefore, this one is wrong. And unlike charges attract each other, it is correct. Therefore, assertion wrong, reason is correct. Therefore, answer assertion false, reason true, fourth one. Here also, Five identical metal plates 1, 2, 3, 4, 5, each of area A on one side are fixed parallel and equidistant d to each other. The plates 1 and 4 are joined by a conductor and plate 3 and 5 also joined by a conductor as shown in the figure. The capacitance of this system between A and B. See here, this is the conductor A, therefore this is A. These two are connected with B, therefore this one is B, this one is B. And this I am taking C and this one also C. Therefore here there are four potential points are there as a 2, A and B and C. I have to find out in between A and B. Therefore A and B, here is another point C. The first two plates are A and C, that capacitor C. A and C, A and C, capacitor C. Next one, this is A and B. Therefore A and B, another capacitor C. And B and C, B and C, C. And this becomes C and B. Again C and B, another capacitor C. Therefore these two are in parallel, therefore 2C, and this 2C and C are in series, and with this parallel C, therefore CAB is equal to C into 2C by 3C plus C. Therefore CAB is equal to CC can cancel, 2C by 3 plus C, therefore 5C by 3, therefore CAB is equal to 5 by 3 into C means A epsilon 0 by D. Therefore 5 by 3 A epsilon 0 by D, option 3 correct. Next one. In a parallel plate capacitor, the distance between the plates is D and potential difference across the plates is V. Energy stored per unit volume between the plates of the capacitor. Energy stored between the plates per unit volume, that is nothing but energy density. U bar is equal to 1 by 2 epsilon naught E square. 1 by 2 epsilon naught E square, but in options there is a potential difference V is there. Therefore E is equal to V by D. Therefore energy density 1 by 2 epsilon naught E square means V square by D square. This becomes epsilon naught V square by 2D square. Therefore answer second one correct. See here. Electrostatic potential at the center of a semicircular ring of radius r and a linear charge density lambda. This is semicircle. If this is a charge q and a radius r, potential V is equal to 1 by 4 pi epsilon q by r. But lambda is equal to charge per unit length. Lambda is equal to, here length of this semicircle is pi r. Therefore pi r. Therefore q is equal to lambda pi r. Then V is equal to 1 by 4 pi epsilon 0. Lambda q means lambda pi r by r. Therefore here r gets cancelled. Therefore this becomes lambda pi by 4 pi epsilon 0. Lambda pi by 4 pi epsilon 0. Therefore option 1 correct. Sir, a conducting sphere of radius 2 centimeter is surrounded by another concentric halo sphere of radius 5 centimeter as shown. Outer surface is given a charge 8 microcoulomb. Charge on the inner sphere when the switch S is closed. See here, when the switch S is closed, the charge flows from the earth to the surface after equilibrium. Therefore, Q is the charge on the sphere, inner sphere. But when it is connected to the earth, therefore potential of inner sphere is 0. Therefore, V is equal to 0. Therefore, the potential of the inner sphere, that is K into, this is Q, by its radius is 2 plus k into outer sphere of charge 8 and its radius is 5, that is equal to 0. Therefore, q by 2 plus 8 by 5 is equal to 0. Therefore, q by t is equal to minus 8 by 5. Therefore, q is equal to minus 16 by 5 microcoulombs. Therefore, answer fourth one. Next one. If the plates of a charged capacitor are dipped in a dielectric liquid partially such that one plate is completely inside the liquid and the other is in air, the level of the dielectric liquid between the plates due to fringing effect at the plates of a parallel plate capacitor, here dielectric length level increases. Therefore, answer second one. This is due to fringing effect. See, these are the another 15 problems from electrostatics and capacitors. These are the problems from NCERT textbook, but not exactly same as from NCERT. These are the modified problems from NCERT textbook. So very important for NEET students. Thank you.